This AkzoNobel e-learning presentation. I'm Keith Campbell, Global Downstream Key Account Manager here at AkzoNobel. Today I would like to present to you the Intercrete range, and specifically their advantage and opportunities in the oil and gas industry. A quick overview of what we'll look at today. We will start with an introduction to Intercrete and the technology behind the range of cementitious mortars and coatings. We'll then take a look at some of the reasons that we need them. Concrete is a strong and versatile building material, but not without issues and limitations. Next, we'll look at the very unique repair and protection solutions in the Intercrete range within upstream and downstream oil and gas. And finally, we'll do a full recap on the presentation's content and the value of Intercrete in the oil and gas market. Intercrete became part of the AkzoNobel portfolio with the acquisition of Flexcrete technologies. The purchase took place in 2017, although Flexcrete had a successful track record stretching back over 30 years before that. The R&D focus has always been very much on innovation and environmentally friendly products. They provide expert knowledge with experienced technical specialists, and they have a worldwide sales network of customers and distributors. If there is a single line that precisely captures the Intercrete product range, this must be it. Exceptionally clever technology, but equally important is producing high-performance products that are easy to apply and in fewer stages. We'll take a look at the complex technology a little later. Let's start with a simple application. Across the range, Intercrete products use basic application techniques, applications of mortars by hand, finished by trowel. The high-performance cementitious coatings can also be brush and rolled, but are easily sprayed if preferred using equipment you're probably already very experienced with. A 60:1 airless unit, a Graco NXT for example, with a 55 thou tip would be ideal. It's easy to apply in large thicknesses. High build layers often means fewer layers than competitor products and can mean more jobs can be completed in a single application. Intercrete does not require bond coats or epoxy primers between coats. No tricky weighing out of part A's and part B's in specific ratios. And bear in mind, every new layer of primer or layer of repair mortar creates a new interface. Each layer a new potential weak point in the system. Greater exposure to poor bond or to surface contamination between coats. This all increases the chances of delamination and premature failure. And Intercrete requires just water to wet out the substrate. Water is your primer, and also water to clean down equipment. As an example of the 3 points highlighted, we can compare the system of a competitor with Intercrete 4801, a high build structural repair mortar, on a simple vertical repair of 80 mm thickness. So for the competitor system, the first stage is to saturate the surface, get the concrete saturated with water, surface dry, so SSD. Then site mix a 2-pack powder and liquid primer 3:1 by volume. You then scrub the primer into the concrete surface. If the primer is allowed to dry, such as working in hot countries, hot temperatures, that will need to be reprimed. And while still wet, apply a repair mortar to 80 mm thickness. The Intercrete system, exactly the same. It starts the same way. We wet out the surface, we totally saturate the surface, make sure there's no ponding water. And when we've done that, we apply 80 mm of Intercrete. It's a far simpler application. There are fewer stages, there's fewer opportunities for mistakes. And bear in mind, many alternative mortars can't reach 80 mm in one application, meaning even more layers and more complex systems. Our next stage is to look at the concrete issues and limitations. Concrete has many strengths, many benefits when used in construction, and we'll look at those. But it's not all positive though. Here are some of the issues. Concrete makes an excellent building material. Here's some of the reasons. It's very strong in compression. It's easily molded and shaped. It can be sourced globally. All over the world you can get hold of concrete in one form or another. It's hard wearing. It has a very long track record. We have concrete structures from around the world 2,000 years old. And it's a relatively cheap product. A cubic meter of concrete is far cheaper than a cubic meter of steel. But now we'll take a look at the other side, the issues and limitations of concrete. Carbonation is one of the greatest causes of concrete failure. During the curing process, the cement hydrates, resulting in a very high alkaline pH of around 12 to 13. It is this alkalinity that protects the reinforcing steel, forming a passivating oxide layer on the surface. Carbon dioxide, naturally occurring in the atmosphere, reacts with the concrete and reduces the pH to a level where the passivation ceases and the steel reinforcing is unprotected against attack and corrosion. Corrosion byproducts have a larger volume than the steel itself. Therefore, they expand, and this results in concrete spalling. The next two slides will demonstrate that. So here we see the reinforced concrete in section. The surface of the concrete carbonates almost immediately, and the carbonation depth will increase faster or slower due to the porosity of the concrete and the variability of the strength and quality. The more porous the concrete, the quicker ingress towards the steel. You can see the green area is the carbonated layer. The steel is still protected by the concrete. And sometime later, the carbonated layer has reached the depth at which reinforcing steel can be found. And obviously, if there is less concrete cover, this will happen sooner. The thickness of concrete cover is critical, and this is something we'll return to later. The ingress contains everything required to corrode steel, and that's exactly what begins to happen. Because corroded steel occupies a larger volume, it needs to expand, and this is when the forces of expansion can force the concrete to fail and break away. And this is the result. We have all seen examples of this in our everyday lives. Looking at the photos, one thing is quite apparent. There does not appear to be anything like enough concrete cover to the steel. This would have caused the process to take place far sooner than usual. Another threat to concrete and its structural stability comes through chloride attack. Chlorides, often in coastal environments or in de-icing salts, work similarly to the carbonation process, penetrating through the concrete to corrode the reinforcing steel. From there, the process is fairly much the same. The steel expands due to corrosion, forcing the concrete to spool. It is important to defend concrete here. Both carbonation and chloride attack do not cause concrete to fail. In fact, it could be argued that carbonated concrete is a stronger, better concrete than uncarbonated. Carbonation and chloride attack the steel, not the concrete. Concrete may fail through impact damage, on jetties and pier legs for example. This strong, robust material can only take so much impact. Concrete has very limited resistance to chemicals. Being alkaline, it is particularly poor in contact with acids, even relatively mild ones. Because concrete is also porous, chemical solutions can work through unprotected concrete at quite a rate. Poor workmanship. The photographs tell the story here. Poorly designed, poorly poured, and poorly compacted concrete make the journey to the steelwork so much easier. You can even see the reinforcing in the first photo. Apart from a lack of cover and protection, poor workmanship can make big differences to the strength of the structure and its ability to accommodate loads. And finally, freeze-thaw damage, a breakdown we've all seen. Due to concrete being porous, water soaks into it, and if the temperature drops and the water turns to ice, it expands and starts to break up the surface. This is a weakness of concrete, no blaming the steel here. So returning to the tagline, we covered the simple application earlier. So let's have a look at the complex technology part. Prior to getting involved with the complexities of the technology of Intercrete, we'll first have a look at the common features and benefits of the products. They're all water-based, non-hazardous, zero VOCs, clean your equipment with water. There's a simple application. both in ease of application itself and in keeping the number of stages to a minimum to prevent errors. Intercrete cementitious products are all ordinary Portland cement based. Not only does this make a natural, compatible and strong interface, it also means repair and parent substrate react similarly to change, rate of expansion and contraction as temperatures change, for example. And all products have full resistance to water pressures up to 10 bar or 145 psi. This is for both positive pressure, direct pressure onto the surface, and negative pressure, pressure from behind, groundwater forcing it in from into a basement, for example. And they all apply directly onto damp concrete and are all compatible with newly poured fresh concrete. We discussed previously how one of the biggest factors that affect the speed of progress of breakdown caused by carbonation and chloride attack is the porosity of the concrete. Concrete contains voids, entrapped air bubbles and capillaries, and the more there are, the quicker the route to the steel. The photograph shows that when viewed magnified, concrete can be similar in structure to a sponge. This is quite a busy slide, but it's important as it shows the entire Intercrete design concept. The large green areas are sand. The smaller black ones are the ordinary Portland cement. Everything else, including the coated glass fibers, polymer films and particles as small as 1/10 of a micron, all serve to create one thing, an ultra-dense matrix for the mortar without porous roots that support moisture ingress. So, when viewed side by side with our magnified concrete photo, the magnified Intercrete is significantly denser, a much more tightly packed matrix. On that photo, the large grey areas are the sand and the smaller white ones are the cement. So the theory hopefully makes sense. Don't give moisture an invitation in. But let's look at whether it is effective in practice. Taywood Labs, now Vinci Technology Centre, have been testing our cementitious coating Intercrete 4841 to determine chloride ion diffusion, the ability for chlorides to travel through the coating. The system has been on real-time test continually since the 1980s. And 30 years on, the old uncontrolled sample showed diffusion within the first month of test. 30 years on, Intercrete 4841, no steady state of flux recorded after 30 years on test. This is a very important point. This is not an accelerated weathering or salt spray test where conditions are simulated and run for a set time, say 5,000 hours. Then an estimate is made that it equates to maybe 12 years weathering in the real world. This is well-meaning speculation, guesswork. How do we know that Intercrete 4841 will protect your concrete asset for 30 years? Because it's been on continuous independent test for 30 years. 32 actually now. This graphic shows that just 2 millimeters of Intercrete cementitious coating offers the same protection against carbonation attack as 100 millimeters of good quality concrete. And this graphic shows that in terms of waterproofing, even tested under 10 bar pressure, the same 2 millimeters of Intercrete coating offer equivalent waterproofing protection to assets that 6 meters of concrete will. So we've seen some of the issues that concrete is affected by. We've seen the Intercrete technologies designed to address them. Let's have a look at some of the products. And first up, Intercrete 4801, a high build repair mortar. Actually the one featured in the ease of application comparison we did earlier. Prime using just clean water, easily applied up to 80 ml in one application. The gloved hand is an ideal tool and finished off with trowel. Even hand applied, the mortar is dense and void free. High build but also high strength, as strong as a good quality concrete within 60 minutes and nearly double that at 28 days. Next, Intercrete 4802. This is a rapid set cementitious mortar, ideal for returning key transport routes to service quickly. It's easy to apply, it can be used up to 300 ml depth with the addition of an aggregate. High early strength, ready to walk on within an hour, accepts a vehicle in 2, and you can land a plane on it in 4 hours. Intercrete 4820 is a pore filler, screed and fairing coat used for improving irregular surfaces. It can be bag rubbed to fill small defects like bug holes, or troweled to repair large issues like pore compaction, also known as honeycombing, the type you saw earlier. At 3mm, it is also fully waterproof. If you're looking to coat concrete with defects and surface porosity, this can be the consequence: pinholing. Intercrete 4820 creates a dense, smooth surface, ideal to apply defect-free international chemical-resistant linings onto. Intercrete 4840 is a high-performance epoxy and polymer modified cementitious coating, offering long-term protection even onto difficult substrates, perhaps where blasting is not permitted or the surface is permanently damp, or schedules do not allow time for them to dry out thoroughly. Excellent corrosion protection both onto steel and concrete structures. Intercrete 4841, a polymer modified cementitious coating. This one also holds DWI 31 and RAS approval for use in contact with potable water. 4841 has exceptional protective qualities, protecting steel and concrete. This is the coating system on permanent test at Vinci, ideal for reinstating low cover and adding extra protection against chloride and carbonation attack. Intercrete 4842 is a highly flexible cementitious coating with the ability to elongate up to 600% of its original size. 4842 is designed for situations where cracking is likely or structural movement is anticipated. Intercrete 4851 and 4852 are an ideal situation for waterproofing floors and decks, perhaps where there is rising moisture due to the slab not having a damp course, or being below sea level, as was the case with this baggage handling hall at Hong Kong Airport. And lastly, Intercrete 4890 is often described as a decorative coating, and that is true, but it is also a high-performance anti-carbonation coating. Once concrete repairs have been carried out, the asset or building may well look very patchy and untidy, so a uniform coating in a preferred colour can help. But there's more to it than that. If localized repairs have been deemed necessary, it confirms that an issue has been identified as present. And if left open to the elements, failure will eventually appear in other areas too. Intercrete 4890 is truly decorative and protective. Easy application too by brush, roller and airless spray. So now we can take all we've discussed and look at some Intercrete applications for the oil and gas industry. Secondary containment is an area where the Intercrete range offers many advantages over conventional systems. Firstly, we can look at the game-changing timescales we can offer on newly constructed secondary containment. Using Intercrete onto the concrete first, we can make significant time savings, getting the asset into new service weeks earlier. In this example, we compare the application of one of our chemical-resistant linings with a competitor system with an equal number of coats. The timescale starts from pouring the fresh concrete to create the bund. So if we look at both systems need the moisture content to be low enough to accept the coating. Using Intercrete under the chemical-resistant lining, we can go on in 24 hours after the pour. The competitor lining will need to wait 28 days for the concrete moisture to get down to 4% or below. The system application, Intercrete with the international lining, 4 days. Competitor lining, 3 days. We take an extra day obviously because we have the Intercrete coat added. That makes the asset from pouring in the concrete to actually fully lined with the full system 5 days with Intercrete and the international chemical resistant lining, and with the competitor lining 31 days, therefore saving an amount of 26 days. Now just to explain why we can apply international linings and coatings without having to wait up to 28 days for the moisture to drop sufficiently. This is due to the rapid cure of Intercrete. We do have to wait for 4%, the difference is Intercrete gets there far quicker. The graph shows that Intercrete 4802, the rapid set mortar, gets down to 4% moisture content in just 30 minutes. Intercrete isn't only used for fast-tracking new secondary containment projects. Existing secondary containment may have issues too. They are rarely isolated from the ground by way of a damp course, so rising moisture can keep the concrete permanently damp, making protective lining impossible. In more severe cases, the area can begin to fill with water, actually reducing the containment capacity of the bunded area. So to summarise, using Intercrete between new or damp concrete and the most suitable international coating system can significantly speed up applications of coating and lining systems. And it's not just secondary containment. Also with the lining and protective coatings of concrete tanks and vessels, and that's internals and externals. Here's an example of one of our seal coat chemical resistant linings being applied onto Intercrete. This produces a smooth and uniform protective system, completely defect and pinhole free. And remember from one of the earlier slides, if your secondary containment lining has a single pinhole, you don't have secondary containment. Reinstatement of low cover. Earlier we looked at the outcome of low cover, but let's take a minute to understand why it might happen. Some of the reasons for insufficient cover to protect reinforcing steel include the choice of incorrect concrete mix design, complicated reinforcement, and the combination of the above. For example, as building design evolves and architects become more daring, reinforcing can be extremely dense and complicated. Choosing a concrete mix that can't fully penetrate and fill around these complex designs can only lead to problems. Other reasons, movement of the reinforcement during the concrete pour, the actual fluidity of the concrete moving the reinforcing, poor workmanship, as we saw some examples of earlier, incorrect spacers that keep the reinforcing bars spaced correctly, incorrect ones used, and wear and weathering over time, lost cover. Not a case study from oil and gas, but a very good example of how Intercrete can solve real issues with low cover. This was a new substation at the West Ham station in London. Once poured, the floor slab was found to have insufficient cover over the reinforcing steel. A practical solution was required. You obviously can't solve such problems by adding extra concrete. Floors demonstrate this really well. Adding extra concrete would cause major issues with clearances for doors, alignments of escalators, etc. You can't leave it because areas of heavy footfall bring wear, water and chlorides from de-icing salts in from outside. The solution was to use just 2 mm of Intercrete 4841 over a suitable floor primer. You can see the application in the bottom right inset photo, effectively adding many centimeters of cover. Prevention versus cure. With Intercrete, we have proven repair solutions for where low cover results in corrosion and failing concrete. You may need to rescaffold the area or bring in other expensive access methods. Repair means the removal of all affected concrete and possibly reinforcing steel too, and the replacement with a suitable repair system. There are health and safety issues to consider too. It will be very noisy. It will be very dusty. If the asset is part of the production process, there's every chance it will need to be taken offline, and the cost of lost production will far outweigh the cost of the repair. Prevention is better and far cheaper than cure. The optimal and most economical proposal for new concrete construction is to specify the Intercrete 2 mm protective system as part of the construction specification, removing the risk of breakdown caused by low cover later. With the Intercrete system, you'll have exceptional waterproofing, the equivalent of 6 meters of concrete, exceptional protection against carbonation, exceptional protection against chloride ion ingress, and a low thickness and additional weight. You'll have a negligible effect on the weight calculations or clearances. In the first of the two pictured examples, Intercrete 4841 was not used to reinstate low cover, but to enhance good cover. The project is the Gorgon LNG project in Australia, where the system was specified to provide additional peace of mind. The other photo is the Blythe gravity-based GBS turbines project. In this particular case, low cover was identified in local areas, but Intercrete 4841 was specified and applied to all the turbine foundations. The decision returned the turbines to a level of protection that allowed them to achieve their specified design life. 2 millimeters of Intercrete offers exceptional protection for concrete, even in the most arduous conditions. Another opportunity in oil and gas is protection of buried and underground assets, both concrete and steel. Intercrete cementitious coatings have many advantages over conventional paint and coating systems for protecting the assets that will be buried underground. Cementitious coatings protect against corrosion through being exceptionally waterproof. For steel assets, they also protect using passivation, similar to the way that concrete protects uncoated reinforcing bars. They also have good chemical resistance in aggressive soils. Blast cleaning is not necessarily required, nor is a fully dry surface. Cementitious coatings have excellent resistance to impact and abrasion, making them ideal for backfilling. They also have good wear resistance. This is particularly useful for protecting pipeline externals where the internal flow causes vibration, resulting on wear on the external coating. Let's take a look at a couple of oil and gas case studies. This is a seawater intake pipe on a project in Qatar. Intercrete 4840 was applied and was found to be more effective and practical than more conventional coating systems, even in remote field locations. On the externals, the system was ideal for the harsh soils and the challenging backfilling, and the cementitious coatings are unaffected by hot salt contact. A similar situation in Venezuela, where a previously coated gas pipeline required a robust system prior to being backfilled and buried. 48,000 square meters of pipe external was coated and immediately protected, even in punishing daytime temperatures. In terms of protection against water ingress, Intercrete coatings are like encasing your buried assets in 6 meters of concrete. Next, we'll have a look at tank base sealing, an Intercrete solution for tank bottom corrosion. Firstly, let's have a quick look at the issue. Moisture ingress at the tank base exposes the tank bottom to the risk of corrosion. We have a problem in that we have different levels of movement between the steel tank and its concrete plinth. Increasing movement can lead to increasing void size, and that can lead to increasing corrosion, and that can lead to increasing ingress, and the whole cycle starts again. We have a problem with traditional solutions, polysulfide sealants, bituminous coatings, paints, that type of thing, that they weather, they crack, they debond, they fail. And the biggest problem of all, it's a hidden danger. The first time of a corrosion problem can be when the tank base breaches and cargo starts discharging. Let's have a look at the Intercrete solution. It's a highly flexible system, up to 600% elongation. It has excellent adhesion to both steel and concrete. It can be applied onto UHP water jet preparation, so no need to blast in sensitive areas. It's highly waterproof, although it resists up to 10 bar pressure. It's microporous, so it will allow trapped moisture from under the tank base to escape as water vapor. And there's no need for expensive kit or skilled labour. Local labour can be easily trained, and of course it's VOC free, 100% water based, no volatile content. And the Intercrete solution, to seal the gap between the storage tank base and the concrete bund, first of all we prepare the steel and concrete with UHP, and then we prime the concrete using Intercrete 4850, which is a primer. We apply a 1 millimeter coat of Intercrete 440 cementitious coating to the join between the steel and concrete. The elastomeric Intercrete 4872 is a sealing tape which is then pressed into the Intercrete 4840, and the final application, 2 coats of the flexible coating 4842 encapsulate the sealing tape. And there is an example of the system as completed. Some project examples. Let's take a look at a few examples. Valero steel storage tanks in the UK. Several systems tried, but none proved effective. The application was carried out in 2012, and regular inspections continue to confirm the Intercrete system still continues to perform today, accommodating the movement experience when tanks are filled and emptied, while protecting the tank base against corrosion. Another example is Coogee Chemicals in Australia, carried out in 2013. The client required a system to protect the tank base without the need to bring expensive plant and equipment in. And finally, some tank base sealing at AkzoNobel, a company based in Turkey. And a final opportunity now, for this presentation anyway. With many oil and gas facilities being coastal or riverside, jetties and piers have extremely challenging environments to protect against. Chemical-laden atmospheres, regular impact damage, tidal actions, salts, and often very little time to carry out effective protection. Quite a challenge. Intercrete cementitious coatings offer many advantages for the protection of piers and jetties. Intercrete 4840 works very differently to conventional systems. Again, immediate protection through passivation, unaffected by salt water. Blast cleaning is not necessary, and this is a big advantage, as one of the biggest challenges in protecting tidal areas is not having sufficient time to prepare the surface sufficiently. Intercrete 4840 is robust and resistant to impact, and is particularly effective in preventing rust creep if breached. Intercrete products provide long-term solutions for immersed and semi-immersed assets, with exceptional waterproofing from just 2 millimeters of thickness. Hopefully there was a lot of information there in a very short space of time, so we'll just take a moment to review some of the applications and opportunities for Intercrete within the oil and gas market. We have fast, pinhole and blemish-free surfacing for continuous protection in secondary containment. Exceptional protection for buried assets against aggressive soils and abrasive backfilling. Simple to apply repair systems with unrivaled waterproofing protection. Fast, long-term protection to coastal and tidal assets. Easily applied, fast cure repair solutions to keep roots open. Highly flexible protection to tank bases against hidden corrosion. Protective systems for floors and walls that are permanently damp. And of course, our fast-track protective systems that reduce project schedules by weeks. Thank you for joining me for AkzoNobel's e-learning on Intercrete solutions for oil and gas. If you have any questions, please reach out to your local International Paints sales support or via our website as shown.